Now let's take a look at the real number line and set notation. Before we start, we need to review some common notation used when dealing with sets. This symbol, this funny sideways E, is translated is an element of. For example, if you see -3, funny looking E, and then the Z that represents a set of integers, we read that -3 is an element of the set of integers. This symbol, a sideways U with an underline, is translated is a subset of. Example, if we see the natural numbers, then this symbol, followed by the real numbers, we read that the set of natural numbers is a subset of the real numbers. If we draw a slash through those same symbols, it changes their meaning as follows. The set symbol is an element of, with a slash through it, is translated is not an element of. For example, if we write -3, sideways E with a slash through it, the natural numbers, we read this, -3 is not an element of the set of natural numbers. Drawing a slash through the subset symbol is translated is not a subset of. Example, the set of rational numbers is not a subset of the set of integers. Now let's take a look at the real number line. You're accustomed to seeing this in this form. We model the entire set of real numbers on this line. And every real number has a place on the number line. You can look at it as sort of an address. For example, the number pi, -pi, 2pi, -2pi, 9.5, -0.5, -8.2, and 7.6 are all located on the number line as such. If we have two numbers, A and B, positioned on the number line, the number to the left is always less than the number to the right. On this example you see on the screen, because A is positioned to the left of B on the number line, we know that A is less than B. In this class we'll deal often with sets of numbers. We're going to look now at interval and set notation to describe different sets of numbers. The set of all numbers between two endpoints on the number line is called an interval. We have two ways to describe this set you see on the screen: interval notation and set notation. Using interval notation to describe this set, we write parentheses A, comma, B, close parentheses, which is read the set of all numbers from A to B, not including A and not including B. Parentheses indicate the endpoints A and B are not included in the set. It's important not to confuse this with the point AB on the XY axis. When we're using interval notation, we're simply describing all the numbers between two endpoints on the number line. To describe this same set using set notation, we write inside of what I call squiggly brackets X, a bar, and then A is less than X is less than B. And we read this, the set of all X, such that A is less than X and X is less than B. Whenever an endpoint is included in the set we're describing, we indicate that by using a square bracket instead of parentheses, like you see on the number line below. For example, the set modeled on this number line would be described by square bracket A, comma, B, close parentheses, which we read the set of all numbers from A to B, including A, but not including B. In set notation, this becomes X such that A is less than or equal to X is less than B. Some books graph this same set using solid and empty dots in place of the bracket and the parentheses. The set is still denoted the set from A to B, including A, but not including B, using interval notation. Just like we had different ways to describe different subsets of real numbers, we have different adjectives to describe different types of intervals. An interval which doesn't contain either of its endpoints is called an open interval. like you see on the screen. The set described by the set of numbers from A to B, not including A or B, or x such that A is less than x is less than B, or the graph shown on the number line is an open interval. An interval which contains only one of its endpoints is called a half-open interval, like you see below. The set of all numbers from A to B, not including A, but including B, or x such that A is less than x is less than or equal to B, or the number line below, is a half-open interval. So what about the case for an interval that contains both its endpoints? An interval that contains both its endpoints is called a closed interval. The set of all numbers from A to B including both A and B, or x such that A is less than or equal to x is less than or equal to B, or the number line below, is called a closed interval. Sometimes we'll work with a set that contains only one endpoint and then stretches to infinity or even negative infinity, as is the case below, where we have A as the left-hand endpoint and the numbers continue on to infinity. In these cases, where we describe the set of all numbers greater than a particular number A, we write the set from A to infinity, not including A, or the set of all x such that A is less than x. This is also an open interval. In the case where A is the right-hand endpoint and the numbers extend from negative infinity to A, we write the set from negative infinity to A, not including A, or x such that x is less than A. This is another example of an open interval. In these cases where the endpoint is included, not much changes. To describe the set of all numbers greater than or equal to A, we write the set from A to infinity including A, or x such that A is less than or equal to x. This is an example of a half-open interval. Similarly, the set of all numbers less than or equal to A is described using interval notation by the set of all numbers from negative infinity to A, including A. The set of all real numbers make up another open interval, as you'll see now. To represent this set, we write from negative infinity to infinity, with parentheses, or the set x such that x is an element of the real numbers. And as we said, this is an open interval. So let's try it. We're going to write interval notation for each set described and graph the set on a number line. If we're given the set of all x such that 4 is less than x is less than or equal to 9, we'll start by drawing a number line with the number 4, 9, and I put 0 here just for reference. Then we graph with a parenthesis at 4 because 4 is not included in the set, and a bracket at 9 because 9 is included in the set, and shade the number line in between. In an interval notation, we write the numbers from 4 to 9, not including 4, but including 9. Let's try another one. Let's do the set of all x such that x is less than or equal to 3. On the number line, all we need is the number 3. Again, I put 0 on the number line for reference. Then we shade everything to the left of 3 and put a square bracket at 3 because our set includes the number 3. In interval notation, we write the set from negative infinity to 3, including 3.